Bismillahirrahmanirrahim. Welcome to Chemistry Online with Mr. Ahmed Sulaiman. Let's continue our lesson hydrogen ion and acidity. We talked about the hydrogen ion, the first part. Now we have second part of this lesson, which is talking about pH concept. We said that to express the concentration of hydrogen ion like this, it has value 1 times 10 of negative 7, and the concentration of OH negative is 1 times 10 of negative 7 as well. It happens only in the neutral solution. But the scientists found that it's not practically accurate to express the concentration by using molarity. Remember, the square brackets means molarity. So they built a new concept for expressing the concentration, which is pH. We have something called pH and we have something called BOH. But here in our lesson today, we are talking about pH only. So pH is used to classify the solution, whether neutral, acidic, or basic. To express the hydrogen ion concentration, not by molarity, more widely to express the hydrogen concentration by using pH scale. So it's a scale. This scale ranged between 0 and 14. It's like this scale, for example, ranged from 0 to 14. This is pH. If the pH is 7, it means it's neutral. At neutral solution, 1 times 10 power of negative 7. It was, if the solution has hydrogen and hydroxide, it was 1 times 10 power of negative 14. At this moment is, for example, 1 times 10 power of negative 5, 1 times 10 power of negative 3, whatever. It means you are moving in this direction. It means it's the value is greater. Here greater, here greater, comes greater. At this moment, the H positive concentration is greater. It means it's acidic. Yes, it happens for pH scale. It moves from neutral to 0. It means it's acidic. If you move in this direction, it means the value will be less than 1 times 10 power of negative 7. It will be 1 times 10 power of negative 9 or negative 11, whatever. It means the hydrogen ion will concentration will be less than 1 times 10 power of 7. يعني less value of hydrogen. It means basic, not acidic. Yes, in the pH also, if you move from 7 up to 14, it moves in this direction and it's a basic solution at this moment. We have a rule to calculate the pH, which is hydrogen ion and pH. What is the relationship between hydrogen ion, H positive concentration, and pH? Look, pH equal negative logarithm of this concentration of hydrogen ion. That's it. So easy rule. The solution here is a negative logarithm. You have to remember that, of hydrogen ion concentration. Why? Because you have here the concentration will be power to negative something. Negative with negative will be positive, because pH must be positive all the time. It was from 0 to 14, no negative in the pH. Remember that. Let's do an exercise to understand more. If you have a pure water or neutral, and the H positive is 1 times 10 to the power of negative 7 molar, and pH is 7. How come? It's easy. You have here coefficient 1. So it's easy to imagine that if you make negative logarithm of this value, it means you will make this negative 7 here with negative, positive 7, and logarithm of 10 is 1, so the value is 7. Let's see here, pH negative logarithm of the concentration of H positive at neutral solution. So negative logarithm 1 plus negative logarithm 10 to the power of negative 7. It means logarithm 1 is 0, nothing here. And negative 7, because this negative moves here, as I said, negative 7 means positive 7. It's easy to calculate it. You don't need to do all of these steps because it's easy. Why? At the case only if the coefficient is 1. Because if the concentration is 1 times 10 to the power of negative 7, it means if it's 1 here, it means negative 7 here means negative 7, positive 7, because logarithm 10 every time is 1. So negative 7 is 7. So it's easy. If you have concentration of H positive, for example, 1 times 10 to the power of negative 9, so pH is 9, and so on. It's so easy, yes? But if you have another value here, not negative 9 or something else, that means you have to calculate it by this method, this rule. Hydrogen here, pH is 7, it means neutral. If the hydrogen ion is greater than this value, that means pH will be less than 7, as I said. It means acidic. H is less than this, it means pH greater than 7, it means basic. As I said, solution with pH less than 7, acidic. pH with neutral, if it's exactly 7, but solution with pH greater than 7 is basic. You remember that? I will do it again very quickly. If it's 7 here, and we're talking about pH now, if it's less than 7, it means acidic. If it's greater than 7, it means basic, the scale up to 14 here. We have many substances we are using in our life has pHs acidic or basic. Look, if the H positive 1 times 10 to the power of negative 1, it means pH is 1. If it's 1 times 10 to the power of negative 6, it means 6, pH 6, and so on. I told you that before. And let's talk about pH. If the pH is 0 up to 7, it means acidic. 7 is neutral. But if it's greater than 7, I'm talking about pH now. Don't confuse between H positive ion concentration and pH. Here pH greater than 7 up to 14, it means a basicity, has basicity, or it's basic. So pH is opposite to H positive concentration. The concentration here of H positive increases, but the pH decreases. At this moment it's acidic. The H positive here decreases and pH increases, it means basic. The opposite of H positive is OH negative. If you want to talk about OH negative, if the H positive concentration increases, it means OH negative decreases. If the H positive decreases while moving in this direction, it means the OH negative increases. Yes, increases. Why? Because it's basic. Let's do some problems. How to calculate the pH if you want it from H positive. Yeah, that means you have in the example the value of H positive and you need to calculate the pH. If you have like this molarity of H positive, you can express it by this method or this method, 0.001, the same meaning of 1 times 10 power negative 3. So it's easy. I told you if the coefficient here is 1, so 10 power negative 3 H positive concentration means pH equal 3. Yes, it's easy. But what if you have the value with coefficient not 1? Look, if the coefficient 1, so it's so easy to calculate it. The concentration 1 times 10 power negative 2, it means pH is 2. What if the number of coefficient is not 1? You have to follow the rule. Let's do an example here. What is pH of solution with hydrogen ion concentration? H positive ion is this value. Now the coefficient is not 1, so you have to follow the rule. Look, pH equal negative log H positive concentration. You have the H positive now, so put it here and calculate negative log of this value. You will get the value by calculator. You will get the value. So you have to follow this rule and find out the result. Look, negative log of this value you got, it's negative. You found this negative 9.37675, and the value of pH is 9.38. What is meant by this value? This value indicates the solution here is acidic, basic, or neutral. It's greater than 7. pH now, we're talking about pH now. Greater than 7, it means it's basic, yes. Because we said less than 7 acidic, more than 7 basic. How can we do the opposite? If you have pH and you need to calculate H positive concentration, what can we do? Let's do it. If you have pH 9, for example, and you need to calculate the H positive, it's easy. If it's 9 whole number, whole number here 9, it means H positive concentration 1 times 10 power negative 9. So you can get this from this easily. But if you don't have this value whole number, if it's 9.3, 4.7, anything like this, what can we do? You have to follow the rule, which is the same rule, but you have to use anti-log. How? Anti-log? Look at this example. You have pH here 6.35. Okay? And we need to calculate the hydrogen ion concentration of this solution. So we have pH and we need concentration of H positive. Let's follow this rule. Because you have pH equal negative log H positive concentration, so pH is negative log H positive, but we need H positive only. Okay. If negative log H positive equal this value, because you have this value, so anti-log means make the in the calculator inverse log. That means logarithm of H positive concentration, this value. H positive only means anti-log this value. Anti-log this value means inverse log. The same, but you have to use inverse log. this value, you will get the concentration of H positive. طب what if he needs pH, but he needs pH, okay, but from OH, not H. We explained if we have H positive, we can get pH equal minus log this H positive. But if you have OH not H to calculate pH, what can we do? You can use ion product constant to determine H positive for a non-OH. Then you will calculate the H positive from pH. How? Let's see this example. What is the pH solution if you have OH negative here? Concentration, this value. We have different methods. To find H positive from this OH, it's easy. You have OH here, concentration. First, you can get H positive. You remember this relationship? Kw, which is 1 times 10 of negative 14. You remember when we needed to calculate H positive, what did we do? H positive equal this value 1 times 10 of negative 14 divided by OH. That's what we are going to do now. So you will get H positive easily. Look, H positive equal Kw, which is 1 times 10 of negative 14 divided by OH negative concentration. That's what we have here. You will get the value. Then from this value, we'll convert it into, move the decimal here to make it scientific notation only. Okay. Then you will get from this H, you got the pH easily. pH is equal negative log H positive. You got H positive, so you can calculate pH easily, and the value will be 3.60. This is the end of our lesson today. We got some practice of problems. I hope to understand everything. Thank you, Shabab.